Okay, for those of us that are just joining and remember the goodies, you know what to do. Okay, good evening, everyone. Good evening, everyone. Can you hear me? Okay, good.
Very well, Sam. You are coming out clear. You are coming out loud and clear.
Okay, good.
Yeah, we
Thank you
can hear
very
you.
much. So, this is exactly 8 o'clock. So let's just give 3 minutes, 3 minutes, and we'll kick off. Thank you very much. Just 3 minutes, and I'll kick off. Okay. Good evening, everyone. Please confirm you can hear me.
Very
Okay.
well, Sam. You are coming out
Okay.
Yeah,
loud
we
and
can hear
clear.
you, Samuel.
Okay. Thank you very much for that. So you are all welcome to our monthly session, and um, sorry, I think I'll have to share my screen. So just introduce us to the topic. Our speaker today is Promise Akini, and you'll be it will be taking us on a very interesting topic, which is around software design architecture, the pub and sub principle. You get, and as a software engineer, this is very very important, especially in um, this current trend of using microservices. Get, we are not just relying on monolithic services anymore. We are moving up. We are scaling up. Get, when it comes to scaling. So we are scaling up, and when it comes to scaling, the fundamentals, or one of the prominent talk around scaling your software is microservices, and one of the way to loosely coupled and make your system, your services communicate with each other very easily is this pub and sub model of architecture. So we'll have Promise join us shortly. I think he's having network issue. Just give me a minute, please. Let me dial him in. Just give me a minute. So apologies everyone. Our speaker promise he will be joining us very shortly. Sorry, he's having a network issue. He will be joining us very shortly. Okay, just okay. So okay. The so to um part our time, we have Dashon in here. So I'll just give him I don't know, Mr. Dashon, I don't know if you can just give us some inspiration and okay, Mr. Promise is here. So Dashon, we'll see like you if you can just give us some inspiration and just let's just hear you a bit.
I'll do my best. Hey,
Okay.
this is what we have to do. The thing that we
Yeah.
want to remind everybody is you can go wherever you want. There's infinite ways to get there, but there's no shortcuts. It's stuff like this, putting in the reps. This is how you learn. There's no cheat codes. There's no shortcuts. It's experience. You just got to get the reps. So I'm glad that you're all here. It means a lot that you're willing to put in this time on the weekend. So yeah, let's go. Let's do it.
Okay, thank you very much, Darshan, for that. Really appreciate. Thank you very much. Thank you very much. So, promise, our speaker promise is here, and yeah, I promise you have the floor, so you can carry on. Promise, if you are speaking, you're muted.
No. He's not speaking yet. I think he's trying to set up. He's trying to set up.
Oh, okay,
Yeah.
okay, that's fine. That's fine. Let's just give him a minute, please.
Hey, hello, can you hear me?
Yes,
Can you hear
yes,
me?
yes.
Very well, loud and clear. Loud and clear.
Yeah.
My apologies for coming late. I was thinking it was 30 minutes ahead. I was thinking my own time should be 7:30 p.m. And I was shocked when Jonathan sent me a message that it's time. My projection was that it's 7:30 p.m. my time. I think you said 8. Is it 8:30 to 9:30 or something? 8 o'clock to 9:30. Okay.
8 o'clock to 9:30 West African time.
Oh yeah. So my apologies, sir. So sorry.
Yeah, that's fine.
So let me try and share my screen. Okay. So, somewhere I messaged you. I was saying that maybe we can connect like 30 minutes before the time so that we can check all of these things. But I think I didn't get a response from you or something like that.
Oh, I guess.
Yeah, because I would have loved. I don't like keeping people waiting. Can you see my screen?
Yeah. Yes, we can.
Can you hear me?
Yes, we can hear you. We can hear you.
All right. Thank you very much. Thank you all for joining. I'm so much happy to be doing this. Yeah, thanks everyone who has joined, and thank you, Samuel, for organizing this. Thanks, Jonathan, also for
Yeah.
telling me about this and asking me to do this however I can. Thank you so much. So I'll just start with the introduction, and yeah. So my name is Promise Akeni. I'm a software engineer at JP Morgan Chase. I've been with JP Morgan for about 3 years now. Before then, I was working remotely for a company in Belgium as a Java developer. And before my foray into software engineering, I was actually working as a hardware engineer. I worked about 5 years in hardware engineering before switching to software engineering. So in software, I've had about like 6 years of experience, and in total, I have about 11 years of experience. Okay. So I don't know if I'm speaking too fast, or should I slow the pace? How do you guys like it? Is the pace okay, or should I reduce the pace or increase the pace?
That's fine. That's fine. That's fine.
Okay.
That's
I
fine.
think we are used to this. Yeah.
Okay.
Yeah, that's fine.
All right. So today I'm excited to be sharing a topic that is near and dear to my heart, which says designing decoupled systems in Java using the PubSub pattern as a case study. So we are going to be looking at a conceptual overview where we are going to go through high-level overview and look at the code, and some case study as well. So at the end of this session, I believe we should be able to understand the following. Number one, we should be able to understand what loose and tight couplings are. We should be able to understand what a decoupled system is. We should be able to understand how to design decoupled systems in Java. We should be able to understand what the PubSub pattern is and the various ways to implement the PubSub pattern. So we have the simple PubSub pattern. We have the advanced PubSub pattern. In the simple PubSub pattern, you have a publisher and you have subscribers. So the subscribers is subscribed to the publisher. So anytime the publisher publishes, all the subscribers, they get the message. Okay, so think of you being in an auditorium where you're listening to a speaker just like everyone is listening to me now. There is no way you can filter that message. Everybody gets the same message that I'm reading out from my end here. So it's the same thing as a simple approach. In the simple approach, the subscribers all get the same message. There's no way to filter that message. Now, in the advanced approach, the publisher has more than one topic. So the publisher has a number of topics, and the subscriber can choose which of the topics they want to subscribe to. So for instance, on LinkedIn, I write a lot. So let's say I write about tech, I write about sports, I write about, let's say, music. So you could decide to say that you want to listen to, maybe you want to be interested in my tech talk and not music. So you subscribe to the tech. So you can, somebody else can say, okay, I want to listen to, whenever it talks about music, I want to get that message. So they subscribe to the music section of my topic. Okay. So whenever I send a message, everybody doesn't get that message. Only the people who are subscribed to the particular topic get that message. So that's the advanced approach. Okay. So before we delve into all of these, I would like us to look at the loose and tight coupling in Java, because loose coupling actually forms the basis of designing decoupled systems in Java. I think I'm hearing an echo. Are you guys hearing the echo too from your end? Maybe I should. Is it fine?
No. I don't think there is, but it's fine. The sound is fine.
Okay.
It's okay.
So loose versus tight coupling in Java. So let's say we have two classes, okay? Class A and class B. Now, class A depends on class B. So this is what I mean by class A and class B. I think I have something here, okay? So you have class A and class B, okay? So I can just quickly write that here. Can you see my screen?
If you're displaying your code, no?
Yes, I can see your screen.
Okay.
Is it big enough? Can you see my text?
Yes.
Okay. Are you talking about the power slide?
No. I mean IntelliJ.
So we can see.
No. We can't. We can't.
Oh, you can't see it. Oh,
Yeah.
okay. So let me. I think I was sharing the wrong. Okay, let me share. I should share the whole screen, right? Stop sharing. Share the window. Okay. Share the window. I was just sharing the PowerPoint. Okay. So now you should be able to see this. Can you see this now? Can you see my IntelliJ?
Yeah.
So what are you seeing on your screen?
No, no,
Oh,
not yet. We are not seeing the IntelliJ.
okay. I'm coming. Show my screen anyway. Okay. Can you see my IntelliJ now?
No, 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 no.
No, we're seeing
No.
your browser still. We see the meetup in the Zoom.
Copy. Okay, share entire screen.
Yes.
Yeah. Okay. Sorry for that. Okay.
Yeah.
So I was talking about loose and tight couplings. I was saying, let's say we had two classes, class A and class B. So this is the representation of class A and class B. So class A needs class B. So this B now becomes a dependency of class A. So class A is said to be the dependent class, and class B is said to be the dependency class. Or class A can also be said to be the client of the dependency. Okay. So for loose coupling and tight coupling, in tight coupling, we are usually creating the dependency of A in A. So we have this class B, which is a dependency of class A. So inside class A, we usually create the instances of class B in class A. So whenever you are creating the instances of a dependency in a dependent class, that is tight coupling. So when the implementation details of the dependency changes, class A is aware. So, but in loose coupling, we are actually leveraging abstraction. And we are saying, okay, we don't care about the implementation detail. By abstraction, I mean interfaces. Okay. So we are saying we don't care about the implementation details. We are not creating instances in a dependent class or the client class. Okay, you just create the instance and give it to us. So I have a code sample for the tight coupling, and this is the tight coupling code sample. Okay, so we have, okay, so let's say one day the business analyst just walks to our office and told us that they want us to create a car that uses an engine. Okay, so I was playing with this earlier on, and let me just comment this one out so that I can drive home my points. Okay, so our business analyst just comes and says, hey, you know what, please, we want you to create a car that uses an engine, any kind of engine. We said, okay, you know what, we can just do that. And she says, okay, please do that in 2 or 3 days. So we sprung into action. Now we have our car class, okay? We have the engine class. This is the engine class, right? So the engine has a start method, okay? The start method actually just prints engine start into the console. Now we have the engine, which is a dependency in the car class. The car class is a client to the engine class because it uses the API of the engine. All right. So now this is done. This is working. We run this code and it works. Okay. So this is running and should run just okay. Now this works. Everything works fine. In a day's time or two, the business analyst comes again and says, you know what, there's a business requirement. Every engine should have a name. We want to know the kind of engine that the car is using. So please try and implement modify your implementation to include the name of the engine so that we can actually know which engine a car is using. Okay, so this means that we need to change the way the engine class works. And if you see now, the implementation detail of the engine class has changed. Now, the corollary effect of this is that if you go to the car class can no longer compile because it is tightly dependent on the engine class. Now, if we say, okay, this is just a little problem, we can just quickly just add the name to the engine, to the constructor of the car class and just passing the name of the engine. Okay, if we do this, this will work. But what if tomorrow the business analyst comes again and says there's a business requirement, a new business requirement that says that every engine needs to have an ID. So every engine has a unique identifier. So that means we go back to the engine class and we'll begin to make modifications, and we'll come back to the car class again and we'll begin to make other modifications. So this has become a mess. So when you have a system where you make a change in one class and you need to make modifications in subsequent classes, it might just be a bad design. It might just be that your design is a tightly coupled design. And as much as we can, we should try to leverage interfaces to build loose coupled applications. Okay, so here is an example of how we can fix that problem. So this is loose coupling. So in loose coupling, instead of us having the engine as a class, we have the engine as an interface. Okay, so this is the implementation detail. This is a class implementing the engine. We have a petrol engine, so we don't care about that in our car class. In our car class, we are leveraging interface. Okay, so in the interface, we are just saying the constructor of the car give us, the instance of the engine, and we don't care whatever it is, whether it's a petrol engine car or it's a diesel engine car, we don't care. So here, if we run this runs fine. Even if tomorrow the business analyst comes and says, you know what, we want to change how the petrol engine car works and petrol engine works, even though they say, okay, let's use just one, we don't want to use an ID anymore, we just want to use, it doesn't bother the car. What the car wants is just create this instance of the engine and just give it to us. Okay, so this is how you leverage decoupled, loosely coupled system. You leverage it using interfaces. You build loosely coupled applications using interfaces, because there's one thing that is constant in software engineering, and that is requirements changing here and there. Requirements will always change. Always. There is no static requirement. Every requirement will change. Someday the business wants one thing, another day the business wants another thing. So we must learn to design decoupled systems, learn to design loosely coupled systems by leveraging interfaces. Okay, at this point, I will take a pause if anybody has a question before I proceed. If there is no question, then I will continue. I'll just wait for like 5 more seconds. Okay, all right. So what is a decoupled system? We've talked about loosely coupled system. We've talked about tightly coupled system. And we said tightly coupled system is one where you're creating dependencies in the independent class. You're creating instances of the dependency in the client class. Okay, and loosely coupled system is one in which you're leveraging interfaces and you're not creating the instances in that class. You create the instance and you give it to us. Okay, but now let's look at the decoupled system. And before we look at the decoupled system, let me just quickly tell you a story. Many years ago, somebody came to visit my mom at home. My mom was not at home. So the person dropped the message with me that once my mom returns, I should deliver the message to my mom. Because I was playful and I was very, very forgetful. I relayed the same message to my sister, so that in case I'm not around or in case I forgot, my sister should relay the message to my mom. So when my mom returned, she got the message from me. Now, in the world of the decoupled system, the woman who needs to pass the message or send the message is known as the publisher. Okay, my mom who needs to act on that message is known as the consumer. All right, then I will be known as the message broker, and my sister will be known as the replica. Okay, so I had to replicate that message because I might not be around. So in the decoupled system, we have 2 or more systems communicating via an intermediary. Okay, so this intermediary has to be highly available. That's one of the hallmark of a message broker. By high availability, we mean that this intermediary has to be deployed in several availability zones, so that if one zone goes down, we can fail over to the next zone. So it is highly available. That makes the both applications that are communicating to be scalable, as in to be loosely coupled. So they don't care. So A doesn't care if B is around. B doesn't care if A is available. What A does, A is the publisher. A publishes to Kafka. Kafka in this case is the message broker. So it publishes to Kafka. Whenever B is online, B comes and reads this message. Okay, so if B is down, A doesn't care. A can scale independently. A can shrink and grow in size independently. A can decide to send many messages at a time or decide to send one message at a time. It doesn't bother B. Whenever B comes back, B is going to read the message and thus do its job. Okay, so this is how we build decoupled systems. We actually leverage a third-party system, which is known as most times the message broker, and the message broker has to be highly available. So we build the decoupled system by leveraging a third application known as the message broker that receives the message from the publisher and keeps the message until the consumer comes to pull the message from the message broker. So this is just a high-level overview of a decoupled system. A decoupled system is one where one or more applications communicate through an intermediary so that they can scale independently, so they are not tightly coupled. So the message broker is the one that is actually doing the decoupling so that both applications can actually communicate without them being aware of each other. Okay, so that's about the POP-SOP. That's about the decoupled system. Okay, so now let's look at the POP-SOP pattern. Okay, the pop sub pattern. Pop sub simply means publisher subscriber. So a publisher is somebody who sends a message, okay, and subscribers are people who are interested, or systems who are interested in that message. The publisher can be a system, it can be a person. For instance, I write a lot on LinkedIn, and if you follow me, you are like you're subscribing to my messages, so that whenever I write anything on LinkedIn, you can see it. So people go the extra mile of turning on notifications so that when I post, they get the message. Okay, so this is just the real world application of pop sub pattern. You have somebody or a system that sends a message, and you have subscribers who are interested in that message. So the subscribers, they subscribe. There is a button they can click, which is like an API, an exposed method that they can actually invoke to subscribe to that message. So when they invoke that method, they are added to the list. So the subscriber, the publisher, has a one-to-many relationship with the subscriber. So he has a list that it maintains, that whenever the subscriber actually clicks on that button, he adds that subscriber to the list. And whenever the subscriber unsubscribes from that message, he removes the subscriber from that list. So the pop sub pattern is one in which the subscribers who are interested in the publisher's message subscribe to the publisher so that they can receive the messages whenever the publisher publishes. And we have, like I said earlier on, we have two types. We have the simple one in which the publisher publishes and all subscribers get it, just like you're hearing the sound of my voice now. There's no way you can filter it. If you're not interested in it, you can just leave. That's you unsubscribing. But so long you are still here, you would get the same message. Everybody gets the same message. There's no way to filter that message. Okay, that's the simple approach. Now, in the advanced approach, and we are going to look all of these in the code. In the advanced approach, you have to decide which topic you want to actually subscribe to. So that means the publisher will have more than one topic. Okay, so for each topic, we have a list or a set of subscribers. So you subscribe to the particular topic you're interested in. So when the publisher publishes on that topic, all the subscribers, they get the message from that topic. So that's basically what the pop sub pattern is. Any question at this point, or should I proceed? Okay, so applications of pop sub pattern. We have message queues, we have Kafka. In message queues, most times when you use message queues, you have a system that wants to send a message to a particular consumer. So for queues, most times you have one consumer reading from the queue, So let's say we have two systems, A and B, and we only want to have one consumer for that message, just one consumer, only one consumer. Okay, so you actually use a queue in that situation to decouple systems. So a publisher publishes to the queue, the consumer reads from the queue. So once the consumer reads from that queue, the consumer actually deletes the message because it's only one consumer. So once the consumer has processed that message successfully, it is deleted. The message is deleted from the queue. But for many subscribers, you don't want to use a queue most times. You want to use like a message broker where you leverage topics. Okay, so you have subscribers subscribe to a particular topic, so they choose the kind of message they're interested in, like Kafka. So for that one, you have durability of messages because you have many people reading the message. You don't know when somebody have read the message or when somebody else has not read the message. So that message, you want to keep that message for a while before you delete that message. So different people can actually subscribe to a particular topic, and get the message. Different people or different systems can subscribe to a particular topic and get the message whenever the publisher publishes to that. But these are just systems. In Java, we don't have systems. In Java, what we have is we have classes. So if I open my IDE, and I believe you can see my IDE right now. So in Java, we don't have system. What we have are classes. So classes for us, they act as system, they act as systems. Now, we use classes to create objects. So classes are blueprints for creating objects. And what do we do with objects? We actually get information from the object and execute those information. For instance, you have a person class, you're doing person.get a person class, and you create an instance of the person class. Okay, so you get person.get name. You're not interested in the object itself. You're interested in the information the object carries. The object carries the name of the person. The object carries the ID of the person. The object carries different information. So what we need are the information in those objects, okay? But for us to create an object, we need the blueprints, and the blueprints are the classes, okay? So we leverage classes are the systems that we have in Java, okay? So I'm going to be walking us through the code sample for building the different kinds of pop sub pattern. We have the simple approach, we have the advanced approach, and there is also my approach. I will explain to you why, in a way, I kind of disagree with the way the simple and the advanced approach are implemented. I will explain to you why I kind of don't really agree with them. So I wrote my own implementation, which is open to criticisms. Okay. So now let's look at the simple approach, the pop sub pattern. Now, like I said earlier on before, in the pop sub pattern for the simple approach, you have the publisher. Okay. The publisher publishes the message and everybody gets the message. Okay. So before you write code, you need to understand high level functionality of anything, because writing code right now is one of the easiest things to do in the world. You have ChatGPT, you have LLMs to leverage on. Even if you don't know how to write the code, you can actually, just tell it what you want and it gives you the code. So understanding high level is very important, so that if something breaks along the line, or they tell you, they wake you up at night and say something is not working, you quickly know where to go. So let's just quickly look at the publisher's functionality. A publisher should be able to publish messages. The publisher should have an interface for subscribing subscribers. The publisher should have an interface for unsubscribing subscribers. Okay. Then what is the core functionality of subscribers? The subscriber just receives the message. Just like now, I am publishing the message. It made my message to you guys, and you guys are just listening. You are not doing much. You're just listening to the message. So the subscriber would only have the ability to receive messages. Okay. So based on what we have seen so far, let's look at the interface for the publisher. If I go to my code, you see this is the publisher. So the publisher should be able to publish. This is the message that the publisher wants to publish. A very simple message. If you have a complex message, you can have maybe an object here that says message, maybe message, content of message, ID, whatever. But this is a very simple message. Okay. So now we have the subscribe. So the publisher will maintain a list of subscribers, so that the subscriber, when they subscribe, they can be added to the list, and the unsubscribe functionality, so that when the subscriber is tired of the publisher and they want to unsubscribe, they can actually call the unsubscribe API. Okay, so this is the publisher. So the publisher should be able to publish, subscribe, and unsubscribe parties involved. Now, whoever implements this interface is a publisher. Okay, so we also have the subscriber. So this is the subscriber interface. Okay, so all subscribers, we have a common interface, notify. You could as well call this one get message, receive message, whatever you call it. The most important thing is there has to be an API, a publicly exposed method, that the publisher would call and send the message. So the API has to be consistent. The publisher has to know a consistent method it needs to call from the subscriber to pass in the message. That is why we are leveraging this interface, so that we have a consistent publicly exposed method for all subscribers. Okay, so this is how the publisher knows the API to call to pass the message to the subscriber. All right. Okay, so now Promise is our publisher. So like I said before, I write on LinkedIn a lot. Okay, so I will use myself as an example. So Promise is a publisher. Why? Because Promise implements this publisher interface. Okay, so here in the publisher, I maintain a list of subscribers. So when somebody follows me, I see that the person has followed me. Okay, I know my followers and all of that. So the first port of call is that a subscriber will call the subscribe method. Okay, so when the subscriber calls the subscribe method, what I just do is just that I add the subscriber to this list. So initially, this set, some people use list. So in the wild, if you just Google pop sub pattern in Java, you're going to be seeing list. But I think a set tells a better story than a list, because you want to have unique subscribers. You don't want to have two people subscribe, to the same publisher. Just one is enough. Okay, so that one person doesn't receive the same message twice. Okay, so that's why I'm using a set here. So the first port of call is that the subscriber will call this subscribe API that I want to subscribe. So the subscribers call this API and they are subscribed. By subscribing, we are just adding them to the list. Okay. Now the next thing is I publish a message. So what I'm just doing here is just that I am actually looping through this subscribers collection, and I'm saying for each of them, I am calling the notify method of the subscriber, because I am sure they have the same API since they implement the subscriber interface. Okay, they should have this notify. I don't care anything else. I just know that they will have this notify method, and I'm passing in the message. Okay, so for the unsubscribe is the same thing. I'm just removing them. It's just a very, very simple implementation. Okay, so I am just removing them from the list so that when next I publish a message, they're not part of my subscribers and they won't get it. Okay, so now let's say Samuel, is my subscriber. Samuel wants to get information whenever I post on LinkedIn. So Samuel implements the subscriber interface. By implementing the subscriber interface, Samuel is a subscriber. So Samuel decides to actually implement his own notify method in a different way. Okay, he says, okay, received by this.getClass.getName. Okay, so what this does is that it adds this package to this name. So you have pops up simple.samuel. Samuel wants to get the full name of the class. Okay, but Rose is somebody else who is also a subscriber, and she subscribes, by implementing the subscriber interface. So now she's a subscriber, and she is implementing her own in a different way. She's saying this.getClass.getSimpleName. She just wants to print that she received it, Rose. She doesn't want to give too much information. Okay, she just says, okay, Rose. So she doesn't want to tell you which particular Rose. She just says, Rose, this is what this.getClass.getSimpleName. So she's saying that she gets the message. Okay, so Promise is the publisher in this case. Rose and Samuel are subscribers, and we are actually talking about the simple pops up pattern where whenever the publisher publishes, everybody gets the message. Okay, so this is the implementation. This is actually the code that we are going to run. Now, Promise is the publisher. I create an instance of Promise. Okay, we have Samuel, Samuel is a subscriber. Rose is a subscriber. Now, Samuel subscribes to Promise. Rose subscribes to Promise. So both of them are my subscribers. So whenever I publish a message, both of them should get it. Okay, so now let me just comment this one out so that we can see that in action. So if I run this one, run this. So now I'm publishing this message, how to design decoupled systems by Promise. So now Rose receives it. Rose says, I've received it. I don't want to give you much information. But Samuel says he doesn't care. He doesn't care. Just tell me. I want everybody to know that this is the kind of Samuel who receives it. The Samuel from the pop sub simple package received this message. So both of them are subscribers, but they implemented the way they receive their messages differently. Okay, so now Samuel got tired of my messages, my post on LinkedIn, and he says, okay, you know what, I want to subscribe. So at this point, Samuel unsubscribes. So once Samuel unsubscribes, what happens is that in the set where I maintain a set of subscriber, I will just go there and remove Samuel. Samuel is no longer going to be part of the people who are going to receive this message after now. So once I run this, only root should get the how to design rate limiter by Promise. Okay, so I run this again. So at this point, Samuel has unsubscribed, and now only Rose is actually getting the message. So in the simple approach, everybody who is a subscriber, they get the message. Okay, so that's the simple approach. So at this point, I will take a pause before I go to the next one in case anybody has a question. Okay, so if there is no question, I will move on to the next one. So this is the advanced approach. Okay, so this is the advanced approach of the pop sub pattern. Pop sub pattern advanced. Okay, no. So in the pop sub pattern advanced approach, like I told you before, you have the publisher who has different messages. Okay, and that's different topics. You have subscribers who are interested in a particular kind of message, not all the messages. So the subscribers is subscribed to a particular kind of message, which we call topic. Okay, so this is so what changes is the way we actually have the interface. So if I go back to the slides, the way the functionality of the publisher in a way will change a little bit. So how this works is that this is the high level flow for the advanced. Okay, the publisher maintains a collection, which is a set or list of subscribers. When a subscriber subscribes, they are added to the collection. When a subscriber subscribes, they are removed from the collection. when the publisher publishes, it looks to, okay, this is just the simple approach. Okay, this is what we've looked at in the simple approach. So this is the advanced approach. So in the advanced approach, okay, the publisher has many topics. So the publisher has a one-to-many relationship with the topic. Okay, so I can have like 3 topics, I can have like 4 or 5 topics. Okay, so each topic has many subscribers. So in my tech, let's say I have 2 topics. I have tech and I have sports. Okay, so in my tech topic, I would have a number of subscribers. Okay, so in my sports, I will have a number of subscribers. So each topic has many subscribers. Okay, now the way we can actually map a topic to subscribers is by using a map. So we have a map of topic and subscribers. So the key is the topic name and the value is a subscriber. Okay, so when we want to get the subscribers who are who have subscribed to a particular topic, we simply pass the topic name to the key and we get the subscribers. So once we are able to retrieve the subscribers, then the implementation becomes similar to the previous one that we saw earlier on. So this is what I'm trying to say in essence. Okay, so we have the publish. So a publisher cannot just publish like the simple one. So he has to publish to a topic so that only the subscribers who are subscribed to that topic can get it. If you recall, in the other one, if I go back to the pub sub pattern simple here, which is the publisher, okay, here the publisher just publishes a message because everybody has to get that message, okay. But in this one, it has to publish to a particular topic, okay. Then the subscription has to happen on a particular topic. The unsubscription has to happen on a particular topic, okay. But the subscriber interface still remains the same and the implementation still remains the same. So for the subscriber, but for the publisher, things have changed, okay. So here, this is Promise. Now, Promise is a publisher because he has implemented this publisher interface, which is called the Publisher Advanced. Okay, so what I'm doing here is that I have a map, this map of string set of subscriber. So this map here, it says the topic, okay, the topic and the sets of subscribers. So each topic will have set of subscriber. Okay, so now the first port of call is that a subscriber will try to subscribe by calling this subscribe API. Okay, so they call to say, I want to subscribe to a particular topic. Okay, so what happens here is that the very first time this set will be empty. This set will be empty. This set will not even exist. Okay, so only we have just initialized the map. Okay, but the set inside of here, which maps to the topic, is not available. So the first subscriber that subscribes, so we are checking, this will be true for the very first time. So we are checking, does this subscriber by topic map, does it contain this topic? If it does not contain this topic, simply means that the topic does not exist and there is no subscriber yet. So what we do is that we actually create a new hash set which represents the set of our subscribers. We are going to be adding subscriber to this hash set. So the very first time we're checking if this is going to be true. And once this is true, we are saying subscribers by topic, the map, this is a map. We are putting the topic here as key and we are passing the hash set here, as the value. So now once this is true, this is going to be true for the very first call. So thereafter, we are going to just say subscribers.topic.get topic. So what we are doing is that we are getting the list. So I say get topic, we are getting this hash set, okay? Just add, we are adding subscribers. So it just goes back to this same approach. Once we get the subscribers, we are just adding it, okay? So here I'm just doing a logger.info to see that, okay, the subscriber has been subscribed successfully, okay? So that's the subscribe, okay? Now for the publish, so what happens is that before the publisher can publish, the publisher needs to be able to get the subscribers, and it gets the subscribers by the topic. So now we are saying if the topic does not have any subscriber, okay, if the map does not have the topic, remember the map contains a map of the topic first and the subscriber. So if this is not equals to null, that means that the topic exists. That means that we have subscribers, okay? So we are saying subscriber.get topic, okay? So once we do this call, we are getting all the subscribers. Now we are saying for each of the subscriber, the same thing we were doing before, we are calling the notify API and we are passing in the message. That's what we are just doing here, okay? And the unsubscription, the same thing, okay? So we are saying, okay, if subscribers by topic, which is a map that contains key topic, so if this topic exists, Now, what we want to do is that we want to remove the subscriber from the list. So what we do is that from the set, what we do is that we get the subscribers here. This gets us the subscribers. Okay. Now we are removing the subscriber from this so that when next we publish, the subscriber should not get the message. So this is the advanced approach. Okay. So this is the implementation detail of the advanced approach for the publisher. All right. So now if we go and look at test this out. Okay. So now publisher advanced promise. Now I'm a publisher. Okay. Samuel is still the subscriber. The same subscriber works for this one. So I just maintain the same subscriber, Samuel, Rose. Now, so Samuel and Rose, they both subscribe to the tech topic, both of them. So this implies that whenever I publish to this tech topic, both Samuel and Rose should get this information. Okay. Now, Rose also went further ahead to say, okay, I also want to be interested in the sports topic. Whenever Promise talks about sports, I want to be interested in this. So Rose also subscribed to this sports. Okay. So when I publish to tech, both Samuel and Rose should get it. And when I publish to sports, only Rose should get this one because only Rose subscribed to the sports topic. So I will comment this one out because Samuel unsubscribed here. I'll comment this one out so we can just quickly run this one and see how it works. So once we say subscribe here, what we'll just do is that we get the subscribers with the topic and we save Samuel in the set of the tech topic. Okay. So now if we look at the console, so these are just logouts to show that we've added subscribers and all that. Then this one, now how to code. Rose got it, Samuel got it. Okay. Now this is when I published to the topic, the tech topic. Both of them, they got this one, which is about tech. Now the next one, which was Rose, going to play some football today. Yeah, received by Rose. Now only Rose got this one because only Rose subscribed to the tech, to the sports topic. And now if you go down this code, you see that Samuel unsubscribed from tech topic. And now this implies that once I actually publish any message to tech, Samuel should not get it, only Rose should get it. So if I run this again, at the tail end, you see that Samuel should not get this message, build your own CLI by Promise, because he has already unsubscribed from this tech topic. Okay, so see, build your own CLI by Promise, received by Rose. Samuel did not get it. So this is the advanced approach. In the advanced approach, you have topics. Okay, you have topics, and subscribers will choose the kind of topic they want to subscribe to. So once they subscribe to that topic, any message that is sent to that topic, they get it. You know, only the topic they subscribe to will they get the information or message that is sent to that topic. The ones that they did not subscribe to, they won't get it. But in the simple approach, they get all the messages. There are no way to, you know, separate things there. Everybody gets the same message. So this is the PubSub pattern, simple and advanced approach. I will take a pause here before I tell you why I kind of disagree with the way the PubSub pattern is implemented in the wild. Because if you Google PubSub pattern in Java, these are the kind of implementations you would see. And I will show you a practical example of why I think we need to modify things and how I was able to come up with my own implementation, which is very, very much open to criticism. So I want to take a pause here in case somebody has a question. If you don't, then I will proceed.
Okay, I think the question should come at the when you complete, so that we can.
All right.
Thank you.
So now, if I go to my YouTube page, okay, these are my subscriptions. Okay, so if you see, I am the subscriber here. Okay, but if I click this subscription, okay, these are my subscriptions. So I, being the subscriber, if you see, I maintain a list of publishers. And one thing is consistent about publishers. If I click on any of them, this person is my publisher. Okay, this person exposes an API through which I can subscribe at will and unsubscribe if I wanted to. Okay, so you see, if I click on this one too, this one, or something went wrong. This one, okay, there's an API to unsubscribe and to subscribe. So one thing you would notice is that I, being the subscriber, I am the one who is actually initiating the subscription and the unsubscription. I am the one initiating it, okay? And I also maintain a list of subscription. This is how I think this works in the real world, okay? Because tomorrow, Rose should be able to go to my page and say, you know what, I'm no longer interested in the messages Promise is seeing. And she has to initiate the unsubscription herself. And she has to initiate the subscription if she wanted to, just like I just showed you now. I was the one who actually initiated the subscription and the unsubscription. Okay, so now, but what we've been doing so far, if you look at it, our publisher has been acting like a bully. Okay, this is the publisher. The publisher is the one subscribing Samuel. The publisher is the one subscribing Rose. How would you feel if you woke up tomorrow and Netflix removed like maybe £500 from your account or 500,000 from your account and say, you know what, I will just subscribe to you. You have to by all means watch our videos and watch our movies and all of that. How would you feel? So you have no control. So this is the kind of implementation you see in the wild, where the publisher is the one who is actually acting as a bully, subscribing people at will and unsubscribing people at will, you know. So here, even though I said that Rose actually subscribed to Tech and Sam actually subscribed to Tech, in reality, it's not Rose that is actually doing the subscription. It's not Samuel that is doing the subscription. It is Promise who is actually carrying out, you know, all of these actions. So what I believe is that the subscriber is the one who is paying. The subscriber is the one who is interested in this message. The subscriber should have all the power. What the publisher owes the subscriber is to expose APIs, you know, that do things, and the subscriber will decide whether they want to actually opt in or opt out. Okay, so this is my approach to things based on what I just showed you on YouTube. Okay, so now I have an iSubscriber interface because there's an existing subscriber interface. So what this does is that it adds two more interfaces to this one. So this one has the notify API, and the subscriber has the subscribe, you know, API and unsubscribe API. So this enables the subscriber to be able to initiate actions by itself. So the subscriber now will be able to subscribe and be able to unsubscribe. Okay, so now if you go here, Rose, okay, is now a subscriber who has more control. That's why she has this iSubscriber. Okay, so initially she just looks for a publisher, any publisher. Like I showed you before, there are so many publishers on YouTube. There are so many people whose channel I subscribe to. You know, so Rose can just say, okay, you know what, I want to subscribe to this guy's channel. She goes and say, okay, this publisher subscribe me. She clicks on the button, you know, and what happens is that this makes a call to the publisher's API, and the publisher actually adds Rose to the set of subscribers. So internally, what Rose does is that she says, okay, publishers that are, so she's adding this publisher as part of the publishers, just like I showed you earlier on. Here, I maintain a publishers list. Okay, so Rose actually has the publisher, so she can just wake up one day and say, okay, I want to unsubscribe from a number of publishers, and she unsubscribes. Okay, so now this is the unsubscription. So the same thing we call the unsubscribe API of the publisher. Then we remove the publisher from our list, and that is it. So this is the notify is still the same. Notify works out of the box the same, but we are just added this subscribe and this unsubscribe to it. Okay. Then for Samuel, the same thing applies. The same thing applies. Samuel is now a subscriber with way more control than he had before. So now he's somebody who can actually decide to subscribe and unsubscribe at will. Now, Promise, and again, this is just the simple approach. Okay, so I will leave the advanced approach for this one that the subscriber has more control to you. So this is a simple approach whereby if Promise publishes, everybody gets it. So there is no filtering logic here. Okay, but I believe you can actually, you know, do this because it's just the same thing as the other one, just that you need to help the subscriber to have more control, to be able to initiate subscription by him or herself, you know. So here, the publish and subscribe and unsubscribe is just pretty much the same thing as the one in the simple approach, just pretty much the same thing. Just that now we are giving more control to the public, to the subscriber. Though we expose the subscribe API and the unsubscribe API, you know, but the publisher would never ever subscribe a user. The publisher will never ever unsubscribe a user. Think of it. No YouTuber will say they want to unsubscribe somebody. Everybody wants people to subscribe to their channel, right? So they just expose APIs for you to be able to subscribe and unsubscribe. So we expose this API, but they don't do anything with it. They don't force you, they just expose it. So whenever you feel like you want to subscribe with their channel, you can just actually click the button. So that is how it is supposed to work in the real world. Okay, we expose this, but internally we are never going to call this ourselves. We have to leave the call to the subscriber. Okay, so if I go to the here and test it, no. Okay, now this is trying to test it. So publisher promise. Okay, so this is promise. Now Samuel is a subscriber with more power now. Rose is a subscriber that has more control now. Okay, so we have subscribers now initiating subscription. Now Samuel has the power now to say, you see what, I want to subscribe. The publisher just exposes the API. The publisher doesn't force anybody to do anything. Rose now is the one initiating the subscription. Okay, so now they have both subscribed. This is the simple approach. In the simple approach, there is no topic. You just subscribe. So they both subscribe. Now whenever I publish, they both get the message. And someone can decide to say, oh, you know what, promise, I don't like you as usual, I'm unsubscribing. Okay, and someone don't subscribe. So if we run this, we're going to see the same output. But the thing you should take out from this is that in this particular approach, you see the subscriber having more power, because the consumers are the ones who should have the most power, not the publishers. The people who are actually paying you money for something should be the one to determine what they want. Your client should be the one to say, this is what we want, and not the other way around. So in the previous implementations, we gave so much power to the publisher. That is tyranny. That is dictatorship. We don't want to run dictatorship here. We want to make sure that the publisher, the people, the masses, the subscriber, the masses, the people, they have the power to do whatever they want to do. So we expose APIs, but we allow them to decide what they want to do with those APIs. So if you see now, I published and they got the message, the same message as expected. Now you have control. Enjoy your freedom. All right. Now you have control. Enjoy your freedom. Now you have control. Enjoy your freedom. Received by Rose. Received by Samuel. Now Samuel at this point, Samuel unsubscribed. Unsubscribe. Okay. So once I say how to build your own Redis by Promise Akeni, Samuel doesn't get the message because he has unsubscribed. Only Rose should get the message. Okay. So that, I think, pretty much wraps up what I wanted to share to you today. And I just have one fun fact, because at the beginning I said, who am I? I used who am I as a way to introduce myself. So who am I is a Linux command that tells you which user you are logged in as. Hence I use it to introduce myself. So at this point, I want to take a pause. I'm so happy that I was able to finish on time, even though I came a little bit late. My apologies once again. So if there's any question, I'm ready to take your questions. If I can't answer, maybe if somebody knows the answer in the audience, you can help me. Otherwise, I will get back to you on that.
Oh, thank you very much, Mr. Promise. I have question and I have query. I have good questions and query based on your your own perception of. Okay. Mr. Dashan is asking the question. Say, what else do you recommend for pub and sub beside Kafka?
What else do I think it depends on your use case. We have RabbitMQ too, but RabbitMQ most times has to do with routing. When you have complex routing logic, you might want to leverage that. But for Kafka, when you are talking about volumes, a lot of volumes and all that, Kafka is like the de facto standard in the industry that you want to leverage on. So I don't see any alternative that much to Kafka, except you don't want to do much volume and you want to just leverage on, let's say, routing logic and all of that. Then you might want to fall back to RabbitMQ. But most of my experiences, I've been seeing lots of Kafka, and I've rarely seen RabbitMQ. But I know RabbitMQ, when you want to have lots of routing logic and all of that, you want to use RabbitMQ. But if you're building small applications, you might also want to use RabbitMQ. Okay, but for large applications, you can start with RabbitMQ if you're building small applications and decide whether you want to go with Kafka. But Kafka usually, you want to be dealing with volumes, lots of volumes, streaming data and all of that, then you go with Kafka. So I think it's a fight between Kafka and RabbitMQ. But volume-wise, millions and millions of data, you want to go with Kafka.
Okay, thank you very much for that answer. Because I had also wanted to ask the question, but I think this has settled it. Okay, like I said, I have both question and I have core based on
Okay.
your own your own said your own preferred implementation or preferred way you want this pub and sub to go. So, but before I ask my own question, I think if there's anybody with question, please you can ask. You can ask your question.
By the way, is this being recorded?
Yes, yes, it is. It
Okay.
is. It is. It is. Okay.
Okay.
Ikechuku, please. Ikechuku, you can ask your question.
Um, you mentioned that we need to give more control to the subscribers.
Okay.
So, don't be offended. I cannot really wrap my head around it quite yet because you said we still need to expose APIs. In your implementation, you gave a set that the publisher was in charge of, was controlling, right?
Okay.
And then you showed methods that subscribe, publish, which although the subscriber was still the person in charge of making those calls. Yeah, and you mentioned APIs that would, I can't really explain it, but
O-
doesn't that count as your APIs too? Those methods that the publishers were calling.
Okay. If you remember, I showed you an example with YouTube, right? You saw that.
Yes, yes,
Okay.
yes. Yes.
So I was just trying to mirror what we have on YouTube, and I also painted a scenario where imagine you woke up one day and you just saw that you subscribe to Netflix, you subscribe to Amazon Prime, you subscribe to different things, and the money in your account had been taken away from you. How would you feel?
I feel bad.
Okay, you feel bad. Okay, so what they do is in the real world, they expose API. You can go to Amazon, register, and subscribe to maybe their Prime, whatever you subscribe. So the fact that we had a set in the publisher, it doesn't mean anything. These are implementation details. You shouldn't be concerned about that. The subscriber is outside of the application. It doesn't know anything. So in the real world, they just expose APIs for you to actually take advantage of. But they like you click on the subscribe button and internally, because why did you click on the subscribe button? You want to be part of the subscribers, right? And that is
Yes.
what they do for you. So once you click the subscribe button, they say, okay, now you are part of the subscription. Now you are an insider now. So whenever we send a message to this topic or whenever we broadcast something on this channel, you get it. That is why you actually clicked on the button, because you want to actually get a message. So exactly what you wanted was what they give to you. So by exposing APIs, we just say we can do this for you, but you have to take the action. But before my approach, I showed you how the publisher was acting as a bully, taking people, subscribing them at will, unsubscribing them at will. And in the world of system design, there is no right or wrong answer. In an interview, whatever you implement, so long you can back it up with arguments, everything is trade-off. There is no right or wrong answer. Everything is a trade-off. So long you can actually defend your cause and say, I'm doing this because of this. These are the trade-off, and this is what my system wants. But from my own perspective, from what I know, if you come and take money from my account without my consent, I'm going to fight you. I need to say this service, I like it, and I want to subscribe. I should be the one to initiate the action.
Yes.
You shouldn't be the one to tell me. I woke up and I noticed that I'm part of. It's just like initiation. You're initiating me into a cult. I don't want that. I have to be the one to take the decision to say I want to subscribe or unsubscribe from this channel.
Thank you very much.
All right.
I understand. Thank you very much.
Okay. Thank you very much for the answer. But I still have my query. It's
Okay,
okay.
I understand. I know what your quarrel will be. Okay.
Yes, Mr. Mark, your hand was raised before Mr. Bright, so you have the floor.
Okay, thank you. I was wondering if the code implementations could be done with more like a real life business domain use case, say maybe bringing a feature aspect in some kind of e-commerce implementation um, of the coupled systems or some form of fintech. So I was wondering it could be that way because sometimes you could Google things like this and you see the kind of generic example thing. Sometimes when you're done studying with the examples and maybe you're looking at some kind of an article, to translate it into some kind of a real world use case when you want to implement maybe in the future or something, sometimes isn't so easy. So I was wondering if the code implementations could be done that way, or at least it helps with relating it with actual real life implementation.
Okay, I'm struggling to understand the question. Okay, but what we have just done is just like laying the foundation, like the building blocks. You won't take this to production and say you want to do this. These are just what's it called, in memory. This won't scale. This won't do well. You know, these are in memory. Your memory is going to be blown up over time. You are just putting stuff in a set. You know, so we don't do this in real world. This is just for you to have the building block of how big systems are built. And if you want to take it a step further, you might want to take it a step further. But this one is not something you want to take to production. Like I said, this was one of the interview questions I was asked. It's just to test your understanding of how to build decoupled systems, how to leverage interfaces, how to do stuff like that. It's not like you want to take this one to, nobody would put something in a set and keep it in memory because you're going to lose that data, correct? You want to persist something in the DB. You want to put things in the DB so that you can read them later on and use them. You don't store data that, client data in memory. So this is just like to give you a building block, give you an idea of how big systems are built, the internal implementation, kind of, but this is not the real world something. This is not something you want to build real world, like this kind of code. No, it won't work. This is just to give you an idea of how the system works, how Kafka, Kafka, you have topic, just like simulating it, simulating how Kafka works and all of that, basically that's just it. This is not something you want to use in production. Obviously, you don't want to store your subscriber in a set because you're going to lose that data once your application restarts. I don't know if I answered your question.
Yeah. Okay.
Well, not really. Maybe I wasn't able to express myself well, or at least what you said is something I understood because in the code implementation you use it just for explanation purposes. Yeah, I understand your response.
Okay.
Okay.
Thank you.
Thank
Just
you
in
very
case, you
much.
can still message me on LinkedIn. We can talk further just in case. So,
All right. Thank you.
Okay, thank you very much. So, Mr. Bright, you are up, and after you, I think there's Mohammed. But Mr. Bright, you can ask a question.
Hi, good evening, everyone. Thank you, Mr. Probis. Yeah, so earlier this month, I used your article on Medium to implement SQS for a task I got, right? And SQS is basically queues. So the topic, for today is, around the pub sub, there's publisher subscriber model.
mm.
So I just want to get a clearer picture. Though this question may sound silly, actually, but is SQS also working on the pub sub, model? And also now, if you check, SQS is very, very cheap. I think they charge, $0.3 over, how many thousand messages, right? So if SQS works on the same pub sub model, how come, SQS is not so publicized? Like, how come it's all about Kafka? And Kafka is very, very expensive, unless if you maybe choose to, self-host it, right? But when you go with the managed one, like Confluent Cloud, it is very much expensive. So is it that Kafka actually works on the pub sub, then SQS works on Q? Like I just want to get like a clearer picture and why it's all about Kafka, right? Yeah, thank you very much.
Yeah, thank you for your question. And I remember somebody was asking about an alternative, and I was mentioning RabbitMQ. Yeah, SQS is also an alternative. You could also use SQS. Okay, so SQS is simple queuing service, if I remember. Okay, so if you see SQS, one of the limitations of SQS is that it has a message limitation. I think 250 kilobytes. I can't remember the specific, but it has that limitation. So your messages cannot go beyond that. So imagine if you are having to send a message with a large payload. You can't use SQS for that because the message size is limited. We're talking about payload of maybe 10,000 lines of payloads and all of those things. I've seen payloads that have grown to like 20,000 lines, of JSON and all that. So you don't want to use SQS for that, So SQS is bound to Amazon. In case you want to leave, it becomes very tricky. It's not generic. It becomes very tricky for you to move from AWS to another platform and all of that. But I think the bottleneck why SQS is not popular. SQS, you want to use SQS if you're very sure that your message size will not be large, because SQS is actually very cheap. Like you said, the pricing is very, very cheap. I can't remember the specific, but I know it's very, very cheap. I think they give upfront free, maybe millions or thousands of messages free, But the thing is, one thing with SQS, the major bottleneck is that the sizing, the message payload. I think you can do beyond 250 kilobytes. So if you want to actually send large data, you want to use that. And most big companies, they're actually dealing with lots and lots and lots of data. And that's why they're leveraging Kafka. And on the pop sub pattern, SQS queues, I don't think it runs on pop sub. Do we? SQS queues, I know you read from the queues. Most times you have, I can't really remember, but on the pop sub pattern, I can't give you an authoritative answer now. I'll have to do some research and maybe get back to you. Is that smart? What's the name of the guy? I might come back to you. I am not so sure if I remember correctly if SQS uses the pop sub pattern, But I know it's a way for you to decouple application. And if one of the drawbacks of SQS is that the message size is limited, is not that great. So most companies deal with lots and lots of data. That's why they don't actually use SQS queues. You want to use SQS queues when you're sure that your messages will not be much, and you're sure it will not be much in the future. Because if it begins to grow, then you begin to re-architect your applications to be able to use something else. So that's why SQS is not that popular, in my opinion.
Okay, thank you very much. Thank you. Okay, now aside from the message size, right? What else can actually make somebody to want to move away, from SQS and leverage Kafka? Is there like any special benefit that Kafka brings, to the table that let's say, the message size is not a problem for the company, right? So is there like any special thing that Kafka brings in to the table that SQS doesn't? Sorry for the questions.
Yeah,
Sorry
no.
for the.
SQS is just a queue. So a queue, most times you have one consumer consuming from the queue. So SQS queue does not have the concept of topics. You only send message to a queue, and you read the message from the queue and you delete the message from the queue. Like I said before, when you want to leverage one consumer per queue, like one consumer to actually read a particular message, you want to leverage queues. So a queue is actually different from like a message broker like Kafka. Kafka has topics, you have partitioning, you have different kind of functionalities that you can't see in queues. Queues basically most times you can be sending thousands and thousands of data in a queue, but you only have one consumer. In most cases, it's like a one-to-one relationship. So but if you want to have a one-to-many relationship, you have many consumers reading from a particular topic. You can have consumer groups, that means an application, you can have different applications actually interested in the message, and Kafka is more durable than message queues. So in consumer groups, you have an application in parallel reading from Kafka topics, but in queues, you just have one message, one consumer basically reading from the queue. So it's I think they have two types of queue. They have the FIFO and they have the standard. The FIFO is the one that guarantees that's first in, first out. So once you send a message to the queue, the next one has to come after that one, something like that. So you read from that. But in Kafka, you have multiple consumers. For the same topic, you can have multiple consumers. So you have the concept of topic, you can partition stuff and all of that, but you can't do those ones in message queues. Message queues are just very simple. They don't have complex functionalities. It's just to read data, but Kafka can give you lots of stuff. I know in Kafka you can actually have an offset where you can say, okay, I want to replay the data. I want to read data from so time to so time. So you can manage that using offset. You can have consumer groups where the offset is managed in the consumers. You can have 3 instances on application reading from Kafka, and in those 3 instances, they'll be able to know where the offset is and know where to read from based on the offset. But you don't have that functionality in SQS. So for me, I want to use SQS when I have a very simple design, and I just want to have one consumer for that queue. But if you want to have complex designs where you want to have different application that fits off from a particular partition, from a particular topic and all of that, then you might want to use Kafka. And that's why Kafka is very popular, because it has lots of functionalities. It gives you lots of different things out of the box, which SQS does not give you.
Okay. Thank you very much. Thank you. Please, one more. The last question, please. Last question. So
Okay.
you talked about different consumer, subscribing to a given topic, right? Which is like one benefit I heard of SQS. Now I'm thinking, there is this stuff called SNS. That is this simple notification system in AWS. Right?
Yeah.
So if I could plug in SNS to my SQS, which I believe is possible, won't I be able to, to publish to different, subscriber, like different consumers?
Okay, so when you plug in your SNS to your SQS, that is called the fan out pattern. Okay, because in SNS, when you publish, the messages are lost. So let's say a consumer is not available when you publish a message, that message is lost. So what people do most times is, they combine SNS with SQS. Okay, so they say, okay, we send a message from SNS to the SQS, and we have, I think, yes, you can actually get that 100%. I think you can actually get that. But then, like the concept of consumer group, I don't know. I don't think you have that concept of consumer group in SQS. I don't think so. That other functionalities, which I don't think you have. And I know Kafka has replicas. They do master slave relationship where the master gets a message and replicates across replicas. So I don't know if SQS has that kind of functionality. Yes, but when you plug your SQS and SNS, when you broadcast the message, you can actually use the final pattern to achieve some kind of things. But now you are combining 2 things when you could have just used one thing out of the box to get the whole job done. But like you said, Kafka is very expensive. So if you're starting out, you might want to leverage SQS and decide in future whether you're going to use Kafka. I don't think you should just start and say you want to use Kafka. And also you have to know, maybe you are designing a cloud native application to know whether you want to use SQS. So those are the things you might want to consider.
Okay, thank you, sir. Yeah, thank you very much. Yeah,
Thank you.
Okay. Thank you very much, Mr. Bright. I think, Mohammed, your hand is up. I don't know if you still want to ask a question. Okay. While that is on, there are questions in the comments section.
Yeah, thank you for the presentation. Someone has already asked my question, the question I wanted to ask.
Oh. That's good.
Yeah.
So there are
Thank
questions
you.
on the
For some reason, I can't access the comment section. I don't know.
Okay, I'll just speak it from here. So the first question here is from Emmanuel Abar.
Okay, I
He's
think I
asking,
can
he
see
said,
it now.
Okay,
Okay, yeah, he's asking that.
let me
Please just read.
Emmanuel Abar. Okay, he said he's making use of class alone, just like you did, without implementing RabbitMQ or Kafka, feasible in real world, or was it just to understand what RabbitMQ and Kafka does?
It's just to understand, like I said, you don't want to put this thing in memory in your application, because when you restart this thing, these are just sets. These are sets, these are lists, these are just Java data structures. When your application restarts, you lose those information. It's just to give you like a sneak peek into how pop-up pattern works, how you can, design this, in your own way, but maybe there is a use case for this, maybe a situation where you don't want to, there is no high reliability on data and all that, but just know that this is not something you want to implement in the wild. Like you want to use this as like production code, because we are just storing data in the set and all that. Maybe you might want to read data from the DB and all of that. But in a nutshell, you don't want to do this in prod. It's just for us to be able to understand the pop-up pattern, how it works, and all of that. Basic functionalities.
Okay, thank you very much. And then the last question here is, do you have any recommendations so we can further learn or read about POP? So what's your recommendation?
I think my recommendation would be for you to study Kafka to understand how Kafka works. Work on Kafka. Build applications with Kafka and all of that. So once you know that, okay, and they're talking about topic, you simply understand the topic. Okay, the promise talked about topic. He talked about how you can actually subscribe to a topic, and only the subscribers to that topic get the information. And understand the concept of queues. That the queue is a subscriber actually reads from the queue. And for simple approach, that once you send a message, everybody gets that message, But for the advanced approach, which is like the topic, everybody who subscribe to that topic gets the message, So for me, I would say read up on Kafka, because Kafka is widely used in big companies. So once you understand Kafka, read about Kafka, learn about Kafka, it will help you a great deal, because you have just laid the foundation. If you build upon this foundation, Kafka is not going to be difficult anymore. You just understand high level. Okay, there is a topic, I can subscribe to this topic, everybody subscribes to this topic, get the information and all of that. So it's just like a build, a build up for you to be able to understand these big systems and play with them. You won't be building your own Kafka, you won't be building your own RabbitMQ, obviously. So I would recommend you read about Kafka. Don't just read about Kafka, try to build small applications with them, play with it, understand it, put it on your CV, and it's going to give you a lot of boost.
Okay, thank you very much. Rose has a question. Yeah, you can go ahead.
Yeah, good evening, everyone. Thank you, Mr. Promise, for this
Thank you.
amazing section. They have asked almost all the questions I had in mind, but when building an event-driven system in Java, like, what are the base, like someone that maybe is trying to implement this for the first time?
Sorry, I think you disconnected somewhere. I didn't get your question completely. You said when
Say
building
that
events.
an event-driven system in Java, what are like the tips that can give someone that is implementing it for the first time?
Okay. First of all, you need to ask yourself, do you really need to build an event-driven application? Because one thing I didn't point out is that tightly coupled system, like when a client calls the server, and the client has to wait for the server to get back the response. These are tightly coupled systems. Tightly coupled systems are not inherently bad. They have their use cases. For instance, you go to Amazon, you want to pay for something. You pay and you wait for the response to say your payment is completed. Then you can move on. So whatever happens under the hood, how your good move from one point to another till it gets to the end of your business. So that's where you want to leverage event-driven application. So event-driven application is one where one application emits events, another one handles the events. So for me, I think the tip I can give you is there a use case for it, or you just want to play with it? If there's a real use case for it, then you can just look at implementations in the wild, look at how understand event-driven application, Google event-driven application, what are event-driven application, when should I use it, and when you should use it is when you want to decouple systems that in such a way that you don't care when something will be done. You don't have to wait for a particular response. If it's something that you want to make a call and in 1 minute you want to get the information, then you can't leverage event-driven applications. So event-driven applications are like, okay, maybe I want to send this thing in the morning and I don't care if it gets processed in the afternoon. I don't want to wait immediately. So that's when you want to begin to say, okay, I want to build event-driven application. When you know that you don't care when it's going to be processed. For instance, you make a request to your transcripts in school. You don't expect them to give you your transcript immediately. You can take this and all of that. So that could be an event-driven application where, okay, you get the request from somebody requesting for that transcript, and you say, okay, you know what, we are processing your transcript. Then you just publish an event to say, okay, just publish the event to maybe Kafka or something and say the information about the person who wants to request a transcript. Maybe the event is going to contain their name, their address, what they want, and all of that. So once you put that event in Kafka, you're publishing it. Maybe another application can read from there whenever the application comes up. For instance, you have your school application. Most times, your school application, they might not be available during the weekends. So you put it on Friday and they come back on Monday and they pull from there. So I think for me, the tip will be, if there's a use case for it, then you can begin to Google and see the implementation, how you can start and all of that.
Okay, thank you very much.
Does that answer the question, Rose?
Rose, are you good?
Yes, I'm good. I wanted to ask if dispute management
If what?
use case for event driven.
Sorry, if what?
Come
Dispute
again, please.
management. Dispute.
So my question is, what is a dispute management? I don't know what a dispute management is. I cannot assume what a dispute management is. So if you shed more light to me to say what a dispute management is, then I might be able to help. So in the dispute management, how does it work? I know event-driven
So
applications can be
it's
expensive. So you don't just do things because you want to do things. There has to be strong use case for it.
yeah, okay. Let's say a customer orders for something, for instance. It was dispatched, but maybe one thing or the other with the logistic company, the item did not get to the customer. So the customer raised a dispute. Okay, this
Definitely.
is what happened. I've not gotten my stuff. And once they lodge the dispute, someone have to be on the other side, maybe back office, to like track what's going on. So at the point where the back office staff is trying to reach out to the third party, which is the logistic company, like, okay, I want to like update the customer, but I don't want like I don't know how to put it, but do you get the scenario?
I get the scenario perfectly. That's a valid use case for event-driven applications. So because you can just tell the customer that, okay, your query has been received. We are processing your query. We'll get back to you. So that one, you raise an event, then another system actually processes the data, and maybe somebody reads it and all of that. So that could be an example of a use case for event-driven applications. Another thing you might want to look at is, do you guys have like the money to pay for that? Is it something you can actually put to the database directly, and whenever the person who should look at that comes, the person just fetch that from the DB? So it's not every time you want to actually leverage event-driven applications, like event-driven apps. You can actually also see, okay, this information this person has lodged, okay, you put it to the DB and you have somebody who is assigned. So once the person comes, the person sees all the dispute and begins to resolve them. So there are different ways around there, So you don't just go and say, I want to do Kafka, I must use Kafka. If your company does not have the money for Kafka, you can look for other means, So once that person sends that message, if I'm working for a company that is not big enough to handle those, I can just say, okay, you know what? Once the person sends through an API, sends a dispute or whatever, I can acknowledge that this has been received. Then I log the dispute to the DB. So we have people who have roles to be able to read this dispute. So when they come, they can read and begin to, attend to those disputes. But I don't think that once you send a dispute message or something to say you have an issue, it should be attended to immediately. No, I think it will take a while. It may take a day or two. It may take a few hours and all of that. So that's one you might, if you guys have an existing Kafka that you want to create a topic for that, or better still, you can just put it in the DB, and somebody who has the role to be able to resolve disputes can come and load it, and on their UI they see all the disputes, they begin to resolve the disputes one by one.
Thank you much. That was clear.
Okay.
Okay. Yeah. Thank you very much. So, Albert, you have a question? Albert. Okay. Emmanuel, can you hear me?
Yes, Manuel, can you hear you?
Okay.
Can you hear me?
Yes.
Yes, I can hear you.
Last week alone, just like we did without implementing RabbitMQ and Kafka feasible. Okay, so you said you gave in-memory storage as one of the bottlenecks, but I don't know. I want to know is if in-memory storage is just the only bottleneck. So without in-memory storage, let's just say I decide to implement database and do that manual stuff. Is it okay? Is it just perfect? So I want to know what are the other challenges if I just decide not to implement RabbitMQ or Kafka and just abstract that issue of in-memory storage. Is there any other bottleneck to that approach?
Okay. So the first thing you must notice, as a software engineer, you shouldn't be reinventing the wheel. If there's a tool that does something, does it well, then there's no point to reinvent the wheel. So what we are just doing is just, sometimes you just want to re-engineer something and see how it works. It's not like you want to build something from scratch. If you have a tool that does something, there's no point for you to actually, because Kafka was built over the years. It has lots of functionalities that I don't think you can even come up on your own with. So the in-memory stuff is not the only bottleneck rather. There are many bottlenecks. But this is just like the basic functionalities, how it works, how we can actually simulate these things. I don't know how Kafka is built, but based on what I know about Kafka, I can say, okay, let me just play with this thing and see how it works. I can decide to say, okay, I want to create my own JSON parser just to test how these things work, But I won't say I want to go on a journey to build something that is going to replace JSON, what's it called, Jackson, library. I won't say I want to build something like that because that library is built by perhaps thousands of engineers. It's not one person, So I just want to build something that I want to test, to play with, just to improve my software engineering prowess and all of that. But it's not something I want to say full personal, except I am really, really determined there is a loophole I'm seeing that I want to explore. Except for that, but for this implementation, there are lots of loopholes. The only loophole is not the in-memory. There are lots and lots of loopholes, so it's not something you want to bank on.
Okay. Bart, are you good?
Yeah, thank you very much.
Yeah.
Okay, thank you very much. Mr. Mark, can go.
All right. Thank you so much, Promise,
Yeah.
for this presentation. Very, very helpful. I want to ask this. Don't you think Kafka so far being the only technology that I see that pops up when it comes to high throughput event-driven systems, when it comes to event streaming, ride sharing, like processing volumes of transactions, like it's as though Kafka has the monopoly on it. So don't you think it's an issue with the whole software engineering world where when we consider building some kind of reliable, scalable systems, we just talk about Kafka alone? What do you think?
So what's the question? Don't I think that maybe we should build our own Kafka?
No. Like as when we want to perform certain tasks, we can have multiple alternatives. But so far, in talking about event-driven systems, we only talk about Kafka in its own category. We can compare it to RabbitMQ, but we point out the limitations of RabbitMQ in certain cases, and also Kafka doesn't really have an equal alternative to it. Don't you think that's a problem generally to software engineering and the way we build systems?
I don't know if I should say it's a problem or those guys are just too efficient. They are just way above their peers. I don't know how to answer that question, but this is a system that has been built so efficiently well that it's hard to think of an alternative. So I don't know if it's a problem, but I know for a fact that if you say you want to build something that's going to rival Kafka, it will take you years. It will take you years. So whether it's a problem or not depends on how you look at it. For me, yeah, I know that monopoly is not good because they might decide to increase cost and nobody would query them because you don't have an alternative and all that. Yeah, that I can say it's
Yeah.
a problem and all that. Yeah. So yeah, I see that as a problem, but I don't have the capacity to say I want to build Kafka. My hand never strong reach that one. So yeah.
All right. Thanks.
Yeah.
Okay, thank you very much. Godfrey.
Hey, go
Hello. If you're talking,
can you I think.
Godfrey, you were speaking.
Can you hear me?
Yeah, yeah, a bit. Can you speak louder?
Can you hear me clearly?
Yeah, yeah, it's coming.
So my question is, what kind of database would you go for? Either NoSQL or SQL for the persistence layer when designing this kind of decoupled system?
So what kind of persistence layer would I go for? And then I think it depends on your use case. Most time it depends on your use case. Basically, if you want to have a highly structured data, then you want to go for SQL. But if your data is not something that is highly structured, where there is no much relationship, and you want to keep things in house, like in a particular document, you want to keep things, and for scalability purpose, you want to use a NoSQL. So it's not just about Kafka; it's about your business needs. It's about the way, like for instance, if you want to design a financial application, a fintech app where you need to have strong consistency, you want to have ACID transactions and all of that, you want to go for SQL. But when you don't need all of those ones and you can be, you know, updating stuff differently, you don't need all those ACID transactions, you want to keep things together, then you want to go for SQL. So those that does not have anything to do with Kafka. It all depends on the kind of data structure you're working with, the kind of your requirements, what you're working on. If your data is something that is highly structured, then go for SQL. Otherwise, you want to go for NoSQL. Because for scalability purposes, no SQL databases, they scale better than SQL databases.
No, thank you.
Thank you all very much for the engagement, Mr. Promise. We really appreciate you. Our time is fast spent. We are supposed to stop 9:30. This is 9:36. Although I have my question, I think I'll private chat
Okay,
Mr. Promise
cool.
on this because my question is clear because you said you prefer the subscribers should be in charge of the publishers. And we know in certain cases, imagine UBA has an issue to report that so and so will be maintaining, will be doing the system maintenance this particular period. Now, even if you don't like UBA, that particular information is useful for you, even though you don't. So they need like for fan out implementation, fan out or something that everybody. If subscribers are in charge, they won't be able to get that message to some extent. I think unless there's a way your thoughts as settles that particular part because there's some message that even though you don't want it, you need it. So that's that's my own take. I think we'll settle that unless you have something to say about it now.
But that one is a completely different case. This is in-house engineering. It has nothing to do with the subscriber. All we are saying is that the subscriber wants to be part of UBA. I want to open my account. It's the subscriber that goes to see they want to open their accounts. Okay. So if the subscriber is tired, he can close their account. But imagine if UBA opens an account for you. That's what we are talking about. If UBA opens an account for you by themselves without your consent, but if UBA says okay, they want to do internal stuff, they want to take control, do some in-house in-house cleanup and all of those, you don't have control. It's an insider's job. you don't expect a subscriber who doesn't have technical capabilities to begin to say they want to do something in UBA. They can't. They don't have the access. They don't have that power. So what we are saying is that the analogy is that the user should be able to say, I should open my account with UBA. UBA should not be the one to open their account with me. I have to initiate that action to open an account, So that's, I think, a better analogy. But saying UBA want to take some services down because they want to do some housekeeping and all that, the client should not have power over that. At least they have informed you. Okay.
Okay. Okay. I think there's the different levels of our probably our seats. Okay, that's fine. Because I was still thinking
It's okay
of
to
some social
disagree
education.
because it's okay to disagree. It's my approach. It's not something that is adopted worldwide. It's just what I feel, and I give you an
Yeah.
illustration. So there is no right or wrong answer. It's all about what you want, how you can defend whatever you've written. It's all about trade-off. Based on what you want.
No. Okay. Okay. That's very good. Thank you very much, Mr. Promise, and thank you all for the engagement. And I think would have to call it a day here. We really appreciate. And for those that drop their email, you'll be getting the alert, not alert. You'll be getting the email notification by tomorrow. Yeah, you'll be getting the notification. We really appreciate every one of us that are here. Dashan has dropped off earlier. I said, okay, we have 4 slots left. Okay, so uh, uh okay, thank you very much. So for those of us that still wants to drop the email, you can drop it now before we wrap up. So Mr. Promise, any word of encouragement? You are like with like 1 million years of experience. So any word of encouragement? How do we push and become even more experienced and remain consistent?
Yeah, the truth is that I still struggle. I still struggle with writing code. I still struggle with some things, and I'm not even gonna lie to you. So for me, I think it's about showing up. Having that belief that every time you show up, things get better. But I can't come here and tell you that it's all rosy for me. It's all easy. I just go to work and in 5 minutes I'm done with my job and I go home. No, some days I spend time without even understanding what I'm doing. Sometimes I don't even know what I'm doing. I remember somebody coming to meet me and told me that, hey, bro, I don't know what I'm doing here. And I'm like, even me, sometimes I don't know what I'm doing. This is a software engineer. So what I will tell you is that it's difficult, it's not easy. And some people think I'm very smart. I'm not very, very smart. And I'm being humble here. What helps me is that I have tenacity of purpose. I don't give up. I'd rather die than give up. If I want to chase something, I will chase it to the end because I have an understanding that if you keep attacking something, no matter how difficult it is, eventually you overcome that thing. So what I would tell you is that there are too many things to learn today, too many conflicting things. So you will just have to sit down with yourself and ask yourself, what do I want to learn? Do I want to learn AI? Do I want to learn Java? So just know that if you want to learn Java, you just need to know Java and its framework. Java and Spring Boot is enough. Whatever you want to learn, just learn that thing and its framework. Just spend time on that thing and don't be jumping here and there. So after a while, you begin to see that this thing is beginning to make sense and it's not as difficult as they had. But when you begin to divide your attention, you want to know this, you want to know that, you want to know that, you're not going to help yourself. So what I would tell you is for you to stay there, work hard, collaborate with people, connect with people who are more experienced than you, people who have been to where you're going to, ask for their help, ask for their assistance, but don't ask them for money because if you ask them for money, they will run away. Just ask for their assistance and all of that. If you have maybe you have anything that is challenging, bothering you, you can speak to people. But just know that you're not alone. It's not like all of us, or it's not like I have my own life figured out. Sometimes I still experience some kind of challenges here and there. But the thing, like I said earlier on, is that I don't give up. Once I have my path mapped out, I follow it to the letter. So for me, I would encourage you to continue. Sometimes the most progress you make is when you're not even seeing the result. So even when the result is not coming, so long you're very sure you're on the right path, just keep showing up, keep putting in your work, even if it's 10 minutes every day, just make it consistent. And over time, you you would thank your future self. You would thank yourself that you didn't give up. You would thank yourself that you stayed the course and you didn't give up. That's how life is. Life will always reward those who don't give up. And if you don't give up, I tell you for a fact that your own story will also be written in gold.
Thank you very much, Mr. Promise, for that. But that money part that you removed, let's put it back. So, thank you very
Except you want me to run away.
Thank you very much. So everyone, have a very good night rest, and we meet again next. We meet again next year for our monthly session, and we have a big plans for us next year. But our weekly session still continues. But we'll be taking a break of the last 2 weeks of December. So we really appreciate you. And again, our boot camp is here. So just keep an eye out for just be alert. The registration form will be very out soon, and the boot camp lasts for 6 months, January to July, June, July, yeah. So yeah, and to be a great one, and there's also an internship opportunity for best graduate students. So just keep an eye up for that. And really appreciate you. Have a nice day.
Thank you. Bye bye.
Thank you.
Thank you very much, Mr. Promise.
Thank you for.
Thank you very much, Promise.
Thank you very
Bye.
much, Mark.
Thank you, Promise.
Hi, Samuel.
Thank you very much.
Hi, Samuel.
Thank you very much.
Can you get us the PDF you used?
Yeah. Everything will be prepared by tomorrow. I will drop everything tomorrow. Okay, thank you.